Hey everybody, this is Mr. Stevenson here, and you're seeing this video because I am at a district training and cannot be there right now. So you should have this piece of paper in front of you, and you should have turned in your work for your homework. And today we're talking about point slope form of a linear function. Before I give you the formula, I wanted to look at why we would want to use point slope form. So we're going to look at example 1 real quick. Last class we talked about y equals mx plus b, which was slope-intercept form. And you need two pieces of information. You need slope and intercept. And so if you look at this graph here, it's not too hard to get that slope, right? It's 2/3. And then if you look for the y-intercept, you can see that it's kind of in a weird place here. It's at somewhere between 1 and 2, a little bit closer to 1. And it's not okay just to guess and say, oh, well, I think that's 1.4, because it's not just 1.4, right? It's more. We need to be more accurate than that. And so at that point, there's several things you could do, but this is a case when you'd want to use point slope form. Okay, so let's start by writing that down. Let's start by writing we use it when we are not given a y-intercept. Because if we're given a y-intercept, slope-intercept form that we talked about yesterday is easier, but we're not always given that information. So sometimes we have to use this one. So let me just show you real quick where this comes from. You remember the slope formula, which was m equals y2 minus y1 over x2 minus x1. If we multiplied both sides by the denominator here, so we're going to multiply both sides by x2 minus x1, and I'm going to do the same thing over here, then basically we get m. I'm just going to rearrange the order here, which is, you can multiply in whatever order you want. x2 minus x1 equals, these guys would cancel, and you'd be left with y2 minus y1. And so this is basically the formula we're going to use, except we're going to write it slightly different. We're going to write it like this. We're going to write y minus y1 equals m x minus x1, right? So x1, y1 is a point, and m is a slope. And if you have that information, then you can write the equation with a line, and there will be some rearranging to do. All right, so let's try that on this problem. We already have our slope, right? We already know the slope here is 2/3, and we just need a point, which it's one of these 2 points that we're given. It doesn't matter which one you choose. Let's go ahead and choose this first one, which is 1, 2, right? And so we're just going to write y minus y1, which is this 2 here, equals m, which is 2/3, x minus the x coordinate of our point. And now that is the equation of a line, but most of the time, and especially this time where it asks here, we need to rewrite it in slope-intercept form. So we basically need to solve this, which means we're going to go ahead and distribute, which will get y minus 2 equals 2/3 x minus 2/3. And then we need to add this 2 to both sides. And that will give us y equals 2/3 x. And we have to do negative 2/3 plus 2, which is going to be 1 1/3, also known as 4/3. Okay, so that's, now you can see the slope is 2/3 and the y-intercept was 4/3, right? So like we wouldn't have been able to guess that would have been 4/3 exactly. All right, let's look at another way you'll be presented with this. Just, more basic, write the equation of the line that passes through the point -5, 1 with slope of 3/5. It might be helpful for you to always write this formula down before you start, so you make sure you get the right things in the right place. So we're going to do y minus the y coordinate, which is here. So y minus 1 equals the slope, which they told us the slope is 3/5, and then x minus, and here's a tricky part, the x coordinate here is -5. Right, so let's clean this up a little bit before we distribute. It's y minus 1 equals 3/5 x plus 5, right? Because a double negative makes a positive. And then we're just going to do the same thing we did over there. We're going to go ahead and distribute, trying to get y by itself. So 3/5 x, and 3/5 times 5. Do some side work here. These are going to cancel, and you're just going to be left with 3. And then we're trying to get rid of this 1, so we're going to add 1 to both sides. And we're going to get y equals 3/5 plus 4. 3/5 x plus 4. Oops. Right, and so that is the equation of the line. Okay, stepping up the difficulty a little bit here. It says write the equation of the line that passes through these 2 points. Basically here, you still need the same thing. You need a slope and need a point. The point here is given, like you have 2 points, you could use either one, but we need to be able to find that slope. And so to do that, we have to use our slope formula, which is that y2 minus y1 over x2 minus x1 from yesterday. And so that's going to give us 8 minus 2 over 5 minus 3, right? Just 8 minus 2, 5 minus 3, which equals 6 over 2, which is 3, right? So our slope is 3, and so we're going to write y minus, right, we're going to fill this in. So y1, let's use this 2, right? We're using this guy, and then the slope goes here, we said was 3, and the x coordinate was also 3 from there, right? From the first point there. And then we just go and finish this thing up, right? Distribute 3x minus 9, and then add that 2 to both sides. And we'll get 3x minus 7. All right, one more like this. Write the equation of a linear function represented by the table below. You guys did some of these on your homework last night, and hopefully you were looking for, like, where's that y-intercept, right? Like, where is the x value 0? But in this case, there is none, right? They're not giving you a y-intercept, so it's a little bit more complicated. This is basically, example 4 is basically the same thing as example 3, except we're just going to have to choose 2 points. And to show you that you can choose any 2 points, I'm just going to choose those 2 points for now, just so you can see that it could be anything. And we're going to start by finding our slope, just like we did before, or just like we did on the last one. So it's going to be m. Oh, sorry. It's going to be m equals, and we're going to put 35 minus 11. So that was just 35, the y coordinate, minus this y coordinate. And then we're going to do over 10 minus 2. Right, and that was these two, 10 minus 2. And that will give us 35 minus 11 is 24 over 8. And you simplify that and you get 3. And so now we can just go back to our point slope formula. Y minus, pick one of these points, doesn't matter which one. Let's go ahead and use this one. So y minus the y coordinate is y minus 11. equals m, which is 3, x minus 2. And then you go through those same steps of distributing and adding 11 to both sides. 6 plus 11, negative 6 plus 11 is 5. And there's your equation in slope-intercept form. All right, so let's practice this a little bit. So what I'd like you to do is you are going to work with your neighbor on a whiteboard. So you're going to send one person from your desk up to get one whiteboard, one marker, and one eraser. We're talking about the little whiteboards up in the front. And you're going to work with your elbow partner. So like the red cards will work together and the black cards will work together. And you're going to take turns doing these. So for example, you know, one person's going to do number 1, and then the other person's going to do number 2, and then 3, and then 4, and then 5, and then 6, and keep your answers somewhere because you will have a chance to check this. All right, so let's do about 5 to 10 minutes to do these 6 problems, right? And then you'll be able to see the answers afterwards to see if you got them right. Okay, so go ahead and pause this video. Go get your whiteboards, come back, and start working on these problems. Okay, so I'm going to show you the answers. So hopefully you've had some time, right? You pause the video, you've had some time to do these, and now we're checking our answers. Okay, so here come the answers, and you can just pause this one again so everybody can look at these and see if this is what they got. And if you didn't get this, then you should check with the neighbor to see what they did and talk about it so you can figure out, well, how do I get that? All right, so feel free to pause again. And now we're going to go ahead and continue. So we're going to go back to our notes sheet, and we're going to go ahead and turn it over to the back side. All right, so now we're on the back side of this, and we're talking about parallel and perpendicular lines. Okay, so if you have never seen this before, which again, that would be kind of strange, parallel lines look like this over here. Is a nice little picture of it. It's like the lanes on a highway, right? They're parallel to each other. They're going right next to each other, but not touching. And then perpendicular lines look like the intersection of two streets, specifically that they're intersecting at 90 degrees. Okay, and there's some special things about parallel and perpendicular lines. Parallel lines have the same slope, right? They have the same steepness, which is why they never intersect. And then perpendicular lines have opposite reciprocal slopes. What that means is if one of my slopes is A over B, then the perpendicular line will be opposite, meaning negative, and then B over A, reciprocal, being flipped. Now, here's another example. If my original slope were negative 2/3, then my perpendicular slope would be positive 3/2, because it's the opposite of a negative. All right, so I would like you to do number 1 and number 2. Try that on your own, because that's just sketching the graph of a line. And I'd also like you to try these ones down here. All right, so we're going to pause the video again and give you about another 5 to 10 minutes to work on these and try to figure them out on your own with your group. And then we can come back and we'll briefly talk about them. So go ahead and pause the video again and work on these. Okay, so you had a chance to work on them. Let's just look at what they are. The number one here says draw a line that is parallel to the given line and passes through 1, -1. 1, -1 is here. It's that little red dot there. So since it's parallel, it's going to have the same slope, right? So this line over here goes up 3 over 1. So our new line is going to go up 3 over 1. It's also going to go in the other direction like this. And so we can draw this line. Hopefully you have a straight edge. I don't have a straight edge on this thing. It looks kind of like that. And then part B of this asks write the new equation of the line. This one kind of turned out nice because we already know the slope. The slope was 3, right? That's that up 3 over 1. And then this one, you can see the y-intercept pretty clearly here. The y-intercept is -4, so we can just write -4 there, and that's the equation of that line. Okay, for the perpendicular line, we're doing opposite reciprocal slope, right? So this one, the original graph has a line of -2/3. Our new line should have a slope of 3/2, right? I already talked about that one up here. So that's up 3 over 2, up 3 over 2. And you can also go the other direction, down 3 over 2. I messed up that first one, didn't I? Up 3 over 2 goes here. And then if you connect those, hopefully again you have a straight edge. If you connect those, you can see, look how they're intersecting at 90-degree angle. It wants the equation of the line, and again, this one kind of turned out nice because there's, it's a nice y-intercept here. So the new equation of the line would be 3/2. That was our new slope. And then -1 because that's the y-intercept. And so that's the equation of the perpendicular line. All right. Down here, all we got to do is look at the slopes to determine if they're perpendicular, parallel, or neither, right? So we just find where's the slope. Here it is. Are those the same, opposite reciprocal, or neither? In this case, those slopes are opposite reciprocal. So these ones would be perpendicular. In the next one, we look at -3 and -1/3. Are those the same, opposite reciprocals, or neither? It turns out they're reciprocals, but they're not opposite, right? They would need to be different signs to be opposites. So this is neither, right? They're definitely not the same, and they're not opposite and reciprocal. Here we're looking for the slope, which this is in point slope form. So this is your slope, right? That number next to the x is your slope. So both slopes are 5, which means the slopes are the same. Therefore, these are parallel. And then the last one, you have to do a little bit of work, right? If these two lines are going to be parallel or perpendicular, they have to have the same slope. So we just need to do a little slope calculation twice here, right? So we're going to do the first one, -1 minus 3 over 1 minus -2, and we're going to get -4 over 3. And then for the second one, we're going to do 4 minus 1 over 1 minus -3, and we're going to get 3 over 4. So we have -4/3 and +3/4. So those are opposite reciprocal, so these are perpendicular. Okay, last thing for today, and then if we have some time, we'll practice these things as well. But last thing for notes wise is writing the equations of parallel and perpendicular lines, kind of like we already did, but without like the graph. So here's an example. What is the equation of the line parallel to this line that passes through 1, 3? Right, so we're trying to write the equation of the line. Typically trying to write, if they give us the y-intercept, that's nice, but if they don't, then we're writing it using point slope form. And we need a point and we need a slope. So if it's going to be parallel to this line, then it has to have the same slope. So our new slope is going to be 6 because it has to be parallel to that line, and that will force it to be parallel. And then it has to pass through this point, right? So that means that's my y1 and my x1, right? Because it has to be has to go through that point, right? So I'm forcing it to have a slope of 6, and I'm forcing it to go through that point. And then this is just, the same thing we were doing above. We're going to clean this up. Distribute the 6, double negative makes positive over here, and then subtract 3 on both sides. Now we're going to get y equals 6x minus 9. So this line is parallel to this line here. Notice they have the same slope. And this new line goes through that point 1, negative 3. All right. Example 6 is a little bit trickier, not because it's perpendicular, but because instead of giving us a nice equation where we can see the slope, they give us this, and we cannot see the slope. So what we need to do first is we need to get it into this form. We need to make it say y equals mx plus b, because then we can just see like, oh, well, there's m, that's the slope. I need the opposite reciprocal of that. So in order to get it into this form, we basically need it to say y equals. We need to solve for y. So we're going to try to get y by itself. So we're going to move this 2x. And this problem probably looks familiar. It's very similar to the quiz question you had before. Looks like that. And then we're going to divide by negative 3. Because we're trying to get y by itself. And so that's going to give us y equals. And that's going to split this fraction up. It's going to be 5 divided by negative 3. That's negative 5/3. A negative divided by negative is positive 2 over 3x. If you want to rewrite it with the x in the front, you can, right? Because that's mx plus b form, so you could write it like that. But the important part is this is our slope. And we want, for our new slope, we want the opposite reciprocal. So instead of positive, we're going to have negative. Instead of 2/3, we're going to have 3/2. And then our new line has to go through this point. Okay, so we're going to do point slope form. Y minus the y coordinate, which is 5, equals our slope, negative 3/2, x minus our x coordinate, which is 8, and then clean it up. Negative 3/2 x. Do some side work here if you need to. Negative 3/2 times negative 8 is going to give us 24 over 2, which is 12. So this is going to be plus 12, right? Because a negative times a negative is a positive. And lastly, we're going to add 5. And that's going to give us y equals negative 3/2 x plus 17. Okay, so that is the equation of the line that is perpendicular to that given line up there, right? Notice the slope drops the reciprocal, and it passes through that 0.85. All right, so if we have time, I'll give you some of these to practice, and then your homework is on Delta Math. In the meantime, here are those practice problems. You notice it's multiple choice, so you can kind of see if your answer is working out or not. So, work on this again with your whiteboards, with your neighbor. Whoever's not writing should be helping and talking and either providing moral support or giving some advice on like, oh, I think that's right, or I think you made a calculation mistake right there, anything like that. All right, so give these a try, and I'll put up the answers in about 5 minutes. Okay, here come the answers. Those are the answers. All right, so again, you can pause on this to check it out, and then when we're done, it should be pretty close into class time. We should put our whiteboards back, markers back, and remember that the homework is on Delta Math again. All right, see you tomorrow.